Hello, welcome back to my channel. Today I would like to talk about digital logic. Stay tuned if you don't want to miss anything. Digital logic is a kind of electronic which utilize digital signals. These digital signals cannot have any value or shape like an analog signal, what we have presented here, but have one of two available values and shape like presented in this slide. So we have either high or low value. The other names for this high and low is true or false and 1 and 0. Many modern devices such as smartphones, computers and other devices uses digital logic. Digital logic circuit can be divided to two groups. One group is combinational and the other is sequential. In conventional logic, output ports values changes almost immediately when input ports change. Time needed to propagate input changes to output is called propagation time. Combinational logic cannot remember current state. On this slide we can see in combinational logic that we have two input signals, in 1 and in 2, and we can see the output signals, and as you can see the output signal doesn't change exactly in the same moment when the input time signals change, but there is some time, and this time is this delay is called exactly propagation time. In sequential logic we use clock signal, and this clock is used to control our devices when it's supposed to check input signals and change output signals. In sequential logic the output can change only on the rising or falling edge of the clock, as in this image we are using rising edge to sum the inputs and change the output. And this sequential logic can remember current state. As we can see, the input is changing but the output is the same. As I've already said, in digital logic there are two states, high and low. Special voltage levels correspond to these states. I will be talking about two technologies, TTL and 3.3 voltage CMOS. For every kind of the logic we have some voltage levels which are quite important when we want to talk and communicate between two devices. So let me introduce these voltage levels. First, one of the most important is power supply voltage, called VCC, and in TTL it's 5 voltage, and in CMOS 3.3 voltage is 3.3 voltage. The other important is ground voltage level. This level is in both technologies the same, is 0, and this is kind of the reference voltage. Next voltage level will be VOH. VOH is the minimum output voltage level that a device will provide for the high level of signal. In TTL we have 2.7 voltage, and in 3.3 CMOS we have 2.4 voltage. Next voltage level is VAH, and this VAH is a minimum input voltage level to be considered as a high level. In TTL, this voltage is 2 volt, and for CMOS is also 2 volts. So as you can see, the minimum voltage level, which is supposed to be on the output for TTL, is 2.7, and the minimum voltage to be considered as high is 2 voltage. So there is 0.7 voltage space for any noise, and still output any destination devices should be able to recognize this signal in the worst case. Next level is VEL. VEL is a maximum input voltage level to be considered as a low. If the voltage would be above this VEL, the device will not be able to recognize this as a zero, as a low. Next level is VEL. VEL is a maximum input voltage level to be considered as a low. Everything above maybe will be not recognized as a low level by the receiver. In both technologies, this VEL is 0.08 voltage. And the last level is VOL. VOL is a maximum output voltage level that a device will provide for the low level signal. And VOL for TTL is 0.4 voltage, for CMOS is 0.5 voltage. One of the common questions when people discuss these two technologies, if it is possible, then a device with one of this technology can communicate with a device with another. So let's assume that our transceiver is TTL and receiver is CMOS. So as you can see, in TTL the output voltage can be from 2.7 to 5 voltage. So this, in worst case, this 5 voltage can damage our the second device with CMOS technology. So it's, in this case, it's impossible. However, when a device which is a transceiver is CMOS and the receiver is TTL, the devices should be able to communicate. Why? Because for high level, the minimal output voltage for high signal will be 2.4 voltage. So the output signal for high will be between 2.4 and 3.3 voltage. For TTL, the input signal to be considered as a high need to be above 2 voltage. So the TTL devices will be able to recognize high signal. What about low signal? For low signal, the devices with CMOS technology will the maximum output voltage level that this device will provide for low signal is 0.5 voltage. For TTL, the maximum input voltage level to be considered as a low is 0.8 voltage. So as you can see, this TTL device will be able to recognize low signal from CMOS. Thank you for watching. Please subscribe if you like it. Please give a comment. Thank you.